Hey guys, it's Mr. Decker here. This is Unit 3 of the Animation and Games unit. It's Lesson 5 on variables. Last week you worked on shapes and parameters, and that was a really big lesson that involved a lot of code, so let's get into this one. Computer science standards for this week are create clearly named variables that represent different data types and perform operations on their values. Decompose problems and subproblems into parts to facilitate the design, implementation, and review of programs. Systematically test and refine programs using a range of test cases, and document programs in order to make them easier to follow, test, and debug. Our essential question for today is how can we use variables to store information in our programs? Remembering that this entire lesson is on code.org, make sure you're signed in with your Google account. Your grade for this lesson will be based on your programming in the lesson on code.org. This video is mandatory. Thank you for watching. Let's head over to code.org. I'm already logged in over here. Remember, you navigate to the class this way. We're on Unit 3. We've done Lesson 1. Skipped Lesson 2, we did Lesson 3 and 4, we're on Lesson 5 on variables. So let's go to Bubble 1 here. New code we're learning is variables, and for the vocab, it's a label for a piece of information used in a program. The new code is declaring and assigning a value to a variable and declaring a variable. So let's get started. Bubble 2, it's a prediction. So let's read the code below and make that prediction. Where will the circle be drawn, and what will happen if you change the number in line 1? All right, so line 1's right here. So we've got a variable set up on line 1, and it's tied to this block of code right here that's making an ellipse. So based on what we know, and I'm going to click Show Grid over here, based on what we know about X and Y position, width and height, right, we can kind of guess that if X position equals 50, then X position here is probably 50, right? Which means that, and with Y being 350, all the way down here, and X being 50, I bet our circle will show up right here. So I'm going to say, let's see, it's X50, Y 350, right? So my answer is going to be bottom left corner. And what will happen if I change the number in line 1? If I were to change the number in line 1, then the X position will change and the circle will be drawn somewhere else in the display area. Let's run it and check. Oh yeah, we were right. All right, and then let's check here. If we can change this number, will it let us? No, it won't. Yeah, it will. Sweet. So let's change this to like 200. Reset and run it. And yeah, see, the circle changes its position. So let's finish. Move on. Bubble 3. So I've been having difficulty with this video for some reason. It just keeps telling me that the video is restricted, but it isn't. If you run into that issue, you can always look it up on YouTube and play it this way.
Most apps keep track of pieces of information that change and update as you use the app. For example, a simple game can keep track of your score and the number of lives you have left as you play. Apps utilize the computer's memory to do this, and learning how to use that memory when programming is a really powerful skill. The most common way to leverage a computer's memory is by creating a variable. Now, a variable is just a container for storing a value. And once created, the variable is stored in the computer's memory, and it can be used and updated repeatedly throughout your program. As an example, let's use variables to keep track of the score and the number of lives remaining in a hypothetical game. Creating the variable is really easy. You use the word var followed by a label that you want to give the variable. You can choose any label you want, but it helps to choose a word that describes the variable that you want to store. So let's label our first variable score to keep track of the score. And then we can create a second variable to keep track of lives. Remember these labels. You'll need them later in order to use the variables. We can assign a value to the variable using the equal sign, like this. Let's set our starting score to 0 and our number of lives to 3. Remember, you only need to use the var at the time that you want to create a new variable. A common mistake is to use it every single time you want to refer to a variable. Also, be sure to avoid mixing up the order when you call your variables. The label's got to appear on the left, and the value has to appear on the right.
What's
like
the password
this.
for it?
Not
I'll
like
have
this.
to write it down and bring it down to you.
Often, you'll want to create a variable and assign it a value right away. There's a really convenient way to do this with one line of code. This is sometimes called initializing the variable. It's important to realize that this single line of code is actually doing two things. First, creating the variable, and then second, assigning it a value. Let's take a moment to talk about the equal sign. In many coding language, the equal symbol is called the assignment operator because you use it to assign a value to a variable. And you're probably used to seeing it in math, but in programming, it's a little bit different. If you were in math class and you saw this, something would definitely be wrong. Score can't possibly equal both 5 and 7, but this is not math class. With code, a computer is executing a set of instructions, one after the other. So this would just tell the computer to set score to 5, and then on the next line, set it to 7. In an effort to avoid confusion, programmers often don't use the word equals when we see this sign. Instead, they use the phrase gets the value. So when we see a statement like this, we could read it as score gets the value 7, or score gets 7 for short. Some programming languages avoid the confusion entirely by representing the assignment statements with a sideways arrow, like this. To use a variable, you just refer to it by its label. Anywhere the variable name appears in the program, the value currently stored in the variable will be retrieved from memory. The tricky part is that when using a variable, you often can't see visually what its value is. To bypass that problem, you can use console.log to display the value like this. This is a really handy trick, but remember there's a difference between showing the value of a variable and writing out the variable's label. When text appears in quotes, you're telling the computer to write those literal ASCII characters on the screen like this. But on the other hand, without quotes, the computer assumes that you're referring to a variable called score, and it will attempt to retrieve its value. If you haven't made that variable, then the computer will give an error.
All right, so let's head back into the lesson. Let's click this orange continue button, and we're here. All right, another prediction. In which corner of the screen will the circle be drawn? Hint, click the show grid box. All right. To help you find the exact coordinates on the screen, enter your answer here. So which corner of the screen will the circle be drawn? Let's see. So X position equals 300, which is over here. And Y position equals 100. So the circle is going to be drawn right here. So top right. Oops, not top right, but top right. And we know this because X position is tied to X right here. And what's the Y? So what's the Y is tied to the Y coordinate right there. So let's run it. And we were right. Let's move on to the next one. Debug naming variables. This program has multiple errors caused by bad variable labels. The errors prevent the program from being viewed in block mode, so the code is in text. Below are a few rules for naming variables. Click Help and Tips above to read more. All right, so I do want to show you help and tips right here. And it said to go to naming variables. If you click that, it will pull up a PDF with all kinds of useful information about naming variables. So the naming rules are basically that they cannot include spaces, they cannot begin with a number, be careful with your spelling, and labels are case sensitive, meaning that if you use a capital letter, it's important that your label continues to use that capital letter elsewhere. Camel case, we're going to be using camel case a lot, all right? As we move through this unit and we go through lessons and lessons and lessons here, there are like 20-something lessons in this unit, so it's huge. It's a giant, big bear. So labels with multiple words can be easier to read in camel case. A camel case label looks like this, where you see this example, where size of rectangle is written out like this. It's all like following these rules, cannot include spaces, right? So of starts with a capital O and rectangle starts with a capital R. You don't have to do this, but it makes the nomenclature and the naming of your labels a lot easier to manage and a lot easier to understand. Let's go back to the instructions. So once again, for naming variables, the rules are thus. Labels can't have spaces. Labels can't start with a number. Capitalization and spelling must be the same, exactly the same. So do this. Find the rule each variable label violates. Correct the errors by picking a new name that follows the rules above. So, okay. If your program works, it should draw the image on the right. You should also be able to switch back into block mode. So this is a very good bubble for showing you a few things. So right here, you see we've got these red error boxes. This is indicating that you have errors on these individual lines in your code. And if you hover over that error box, it will tell you, it will give you the gist of what that error consists of, why it's a problem, right? And so the reason why this code is showing up in text instead of as blocks, like you see in your toolbox over here, is because those errors, right? We could click show blocks, but because there are errors, it won't switch to blocks. And when we click run over here in the debug console down here, it gives us this syntax error, right? And a syntax error means that there's an error in the naming of the variables. Syntax is basically text, right? So let's reset this and let's fix these errors. So size of circle, we learned that labels can't have spaces. So we've got to fix this error right here by taking out the spaces. And then let's go ahead and get into the habit of doing camel case. So capital O, capital C. We also learned that labels can't start with a number. So one dimension has to become dimension 1. And then Y location right here, what's wrong with that one? Well, nothing. It's in camel case. It's all one word, no spaces. It doesn't start with a number. So maybe this rule is broken. Capitalization and spelling must be the same. So let's look down here and find where this variable on line 3 gets used. Right here. So what's the difference? Can we spot it? This Y right here is capitalized. This Y is lowercase. So let's fix that. All right. Now, what else? Dimension 1 down here, this needs to be, instead of one dimension, dimension 1. So we're fixing these errors up here. You can see the errors disappear. And then size of circle, we need to match this up. So let's take the spaces out and add the camel case. And it's used twice, so we'll have to fix it in both spots. All right, all the errors are gone. So now let's click this Show Blocks button. The errors are gone. It's gonna work. It's beautiful. Let's finish and move on. All right, bubble 6, using a variable many times. This program has only one variable called petal size, but it uses it 8 different times. This makes it easy to quickly make lots of changes to allow how your picture is drawn. Do this. Change the number assigned to petal size so the red petals touch one another. Try to find the size that makes the most sense. Compare your answer with someone around you. Well, we're all at home or sitting in a classroom with maybe no one else taking this class, so we're just going to have to compare it to what I do. So let's run it. All right, so we've got the no stroke, which means that there are no borders around any of our shapes. We've got our background set to forest green. That's working properly. And let's go back up here to line 1. So this variable we have set is for petal size using camel case, and it's setting the petal size to 50. It's using this size on width and height on each of these down here. It doesn't use it on the flower center, but it could, because the flower center is also set to 50-50, which is the same as the variable up here. So let's see. Let's change this easily by maybe trying 60. Reset, run. And they're not touching yet, right? That's our goal. Change the number size so the red petals touch one another. Let's try 70. Almost. Let's try 75. Reset, run. All right, cool. That works. And so as you can see, this variable petal size is tied to the width and height of all of these lines of code. Each of these ellipses is tied to that variable using the label we created up here. Let's finish and move on to bubble 7. All right, we've got some challenges to complete here. We're going to do each of these and we'll do them in order. So let's start with A. This program uses the variable circle size to control the width and height of a circle. If you make the circle big enough, it will fill up the entire screen, as in the picture on the right. Do this. Change the value assigned to circle size so that the circle fills the entire screen. All right, so right now it's set to 400. And it's a big circle, but it doesn't fill the entire display area. So let's reset. Let's change it to, let's make it easy, 600. Go ahead and make it big. It fills up the entire screen. And we can see circle size is tied to width and height down here on this ellipse. So finish, continue. Let's move on to challenge B. Challenge B says debug variable names. Something is wrong with the program below in which it cannot seem to create the image on the right. Can you fix it? There's a hint here. Variable names can't have spaces. Oh yeah, these are those rules again. Can't start with a number. Capitalization and spelling and names must be exactly the same. So, all right, something is wrong with the program below in which it cannot seem to create the image on the right. Can you fix it? Let's run it. Okay, so we've got some errors here. X hasn't been declared, but it has right there. Oh, this is capitalized. So let's make that lowercase. That fixes that error. And in this one, same thing. Needs to be lowercase. This rectangle should work. Let's reset and run. Cool. So as you can see, even though there was no error on line 7, because there were errors in other places, the entire program was basically completely broken. Even this rectangle wouldn't show up because there were errors above it, right? That's important to remember. Let's continue. All right, we got a cute little bear, little teddy bear. Okay, debug unused variables. In the code below, variables are created, but none of them are actually being used. Can you find spots where they can be used? All right, that's all the instructions we've got. So let's run it. Well, the bear shows up just fine. We've got some issues up here. Center is defined, but it's not called in your program. Ah, I see. So we've got ear size, eye size, and center, but it's not used anywhere down here. So these are set up correctly, but we want to use these variables. So let's do that. So ear size equals 80. So every time we see an 80, let's put ear size in there. So I'm going to Control C to copy that and just Control V it every time I see 80. I don't see 80 anywhere else. So let's move on to eye size. Control C. Eye size is 15. So 15, Control V, Control V, Control V, Control V. And what I'm doing is I'm just clicking in that space and then Control Ving on my keyboard. All right, I think that's all of the 15s. Let's find all of the centers, which is 200, Control C. Close, but no cigar. Oh, here's some. Control V, Control V, Control V, Control V, Control V, Control V. Any more? I think that's all the 200s. If I missed one, I apologize. Run it, and it's still the same because we've tied our variables to our code down here. Awesome. So let's finish that one. Continue. And let's debug the bad naming on D. Debug bad naming. The following variable here can't be used because of bad naming. Fix the name so you can run the program. So that's easy. It's got a space in it, so we'll take that out and we'll make it camel case, shape size like that. And then let's click show blocks once you've got that fixed. And then now it says it's defined but not called in your program because we have size, all the way down through here. So let's Control C and fix this real easy by clicking in the space and Control Ving our new variable label down here. Boop-a-doo. And as you can see, the errors disappear as I'm fixing them. So run it. Beautiful. We've got a stoplight with a white background. Okay. Whatevskis. Let's finish. Continue. And we've done all of these successfully, so let's finish there. We're on to bubble 8. This program currently draws a face, but the eyes are 2 different sizes. Change the program to use the variable for the size of both eyes and run the code to make sure both eyes are drawn at the same size. Okay, so I'm going to run this, see how it works. And yeah, he looks like he's kind of like he just ate something that did not agree with him, right? Change the program to use the eye size variable. Okay, so here's the eye size variable on line 1. And the eye size equals 27. So going down here, line 4, background is green. Yep. The face is yellow. Yep. And the size of the face is 200, 200, and it's located in the middle at 200, 200. The eyes are filled black. Correct. Yep. Ellipse 160, 170. Eye size. Eye size. Ah, I see where the problem is. So on line 13 down here, on this ellipse, it's the other eye, and it's set to 10. So that's the little one. 27 must be this one, the one that's set correctly on line 12. So let's Control C. Whoop, copy that. Control C. Control V. Control V. Okay, so reset and run. And now our eyes are the same size. Cool. Well, that wasn't that hard. Let's move on. all the way onto bubble 9. All right, so we've got more challenges to complete. I'm going to say that you guys have to do A, B, and C. So let's jump in here and do A together. And this one says, draw an image using variables. Draw an image where many of the items rely on a common variable for size or placement. For example, draw a face with variables controlling the size and or placement of both eyes, ears, and nostrils. Once you have your drawing completed, try changing the values of your variables to make sure that the whole image changes together. Okay. So let's run it. Right now we've got those eyes. I'm going to show the grid. I'm going to grab a fill color. I'm going to make a nose. And I want my nose to be blue. And I'm going to make my nose an ellipse. Let's see. Using variables, draw an image. Okay, so it wants me to use variables. So I'm going to grab a new variable, put that on line 2, and let's make this one nose equals. Actually, I don't want to do it that way. I am going to make my nose blue, but I'm not going to do this. I'm going to make some nostrils, and I want them to be really, really small. So let's make them like size 10. Let's make his nose first, though. So down here on this ellipse, I want it to be located at 200, 100. And I want his nose to be size 50. So y, right? This variable equals 50. Reset, run. Perfect. Now let's make some nostrils. We'll tie it to this variable. Go back to drawing in the toolbox. And we're going to use ellipses. We need 2 of them. For the location of them, let's see, 189, 110. For X and Y. And then let's put the other one at 211, 108. And then let's tie this variable to it. Control C. Control V, Control V, Control V, Control V. Reset, run. All right. Oh, let's use fill. And we'll put that on line 9. We'll fill that with black. Reset, run. Cool. They're a little bit lopsided, but I'm okay with it. Nobody's perfect. Friendly face here we're making. Okay. Now let's draw a rectangle. And let's make a mouth right here. So let's start the mouth at 150, 150. And it needs to be way smaller than 200, 200. That would make it giganto. Watch. Let's see. And let's make it go to right there. So we want it to be 100 wide. Set, run. Now he's like gasping. He's like, he's seen a ghost. All right. And then we don't want it to be that tall. Let's make it like 20 height. Cool. All right. We made a face. Finish. Continue. All right. Let's pause right here and I'll be right back. All right. We're back. Let me make sure we're back. Yeah, we're recording. So let's go to B, updating variables. So this one's kind of cool. I really like this one. It takes a minute though. So far we've only ever assigned a value to a variable once, but did you know you can update a variable during a program? Read through the example program we've provided, run it a few times to understand how it works, and then attempt to modify the program to draw one of the following images. We're going to do all 3. So let's jump on in here. So we've got an X label variable as 50 and a Y equals 50. And down here, we're adding two variables using this block right here. So this declares the variable or initiates it, and this one calls it, right? You also call the variable by using the label from the variable down here, right? So right now, when we run this, we've got 3 red circles. So let's work on making this one first. And in order to do that, we're going to just duplicate some code. So let's grab another x equals from our toolbox from the variables drawer. Let's go into the drawing drawer. We're going to grab another ellipse. And we can use this arrow, right? Back it up. Back it in. Let me begin. Try to battle me, that's a sin. All right, that's enough vanilla ice for the moment. And then we've got to grab a math operator from the math drawer. So this is how you navigate through the drawers. Grabbing the plus. We're going to say x plus 50 again. And then we need to match these, right? So this is going to be x and this is going to be y. Reset run, we've got a 4th circle. So now what I can do is be sneaky about it and make it easy. And you can click and drag with your mouse and it will highlight those, Control C. And if I click, you see that little black notch right there, right? And I can move that notch around with my arrow keys up and down. And I Control V. And I've got more, reset run, right? Control V. Right there, Control V, reset run, and I need one more. So Control V again, reset run. We got that. Okay, so now I want them to go down. In order for that to happen, I'm going to have to tie the Y variable to these. So we'll just replace Y, 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 why me, why me? Why are you doing this to me? Putting Y's in here all over the place. And then reset run. Boom. Got it. All right, now let's do the tricky one. So for this one, we are going to go into our variables drawer, grab this one, which is assigning a variable, snap that in, and it's going to remain x. We need to go to the math drawer. We're going to grab the plus, pop that in there, x plus 50. And then we're going to duplicate that line right there. So I'm going to take you and go whack, and take you and go whack. And we're just going to highlight this one, Control C, and then Control V. See, I'm moving my little cursor right here. Control V, Control V, Control V. And I scroll down, you can scroll around using the scroll wheel, or if you're using a trackpad, you can move around as well. Moving that cursor using my up and down arrows on my keyboard, Control V, and then it should look like that one. Awesome. Okay, finish. And then let's do this one, the string variables, and then we'll be finished. All right, for this one, challenge string variables. So far, we've only ever assigned a number value to a variable, but did you know you can give a string value to a variable? Read through the example program we've provided and then modify the program to create new images with different colors. Okay, cool. So run it. We've seen these regular polygon, these shape makers, right, where you can give it as many sides as you want using this value right here. If we go to drawing, right, we'll look at the regular polygon again. See, we've got X and Y position in those first two spots, and then sides, giving it the number of sides, and then the last number or last parameter is the size. So let's mess around with this. Let's change the colors. So click in there. Let's make this one teal. We'll make this one blue. We'll make this one green. We'll make this one purple. Why not? And then down here, let's change the number of sides they each have. 10, 8, 3, and then the last one's a circle because it's an ellipse, not a regular polygon. So let's run it. Cool. So we changed the colors. See, the variable color 1, color 1, color 2, color 2, color 3, color 3, color 4, color 4. So you're tying these variables to these fill colors, and that variable is tied to the color that we told it to be. Beautiful stuff. I love code. Basically, you're telling the computer to do exactly what you tell it to do, right? No user error. The computer did it beautifully. Let's finish. Continue. Basically, we're done with Bubble 9. If you want to go into free play and kind of sandbox this, it gives you some tools to play around with over here. And that be it for this video, guys. I hope you had a good time.